Okay, I'm here with Daniel, and Daniel's gonna show us the thermal management system.
Yeah, so a couple of you guys probably know me. So right now I'm the thermal and HVAC systems lead here at Aptera. So this is going to be our main kind of workbench. Probably a little bit different than what some people might be expecting, but having worked on a bunch of thermal systems before, I can tell you get coolant everywhere. So that's what this is intended to.
So this just contains the coolant that spills. Got it.
Exactly. So even if you just had this being flat here, you get coolant that follows it, and it's still on the ground. So it's quite messy. So yeah, and we will be testing this kind of in the office with a bunch of people around. So we don't want to be having people walk through coolant and track it everywhere. So it's kind of the main purpose here. Down at the end, we have a couple of control boxes. So we'll have high voltage power that comes in to kind of power different heaters and different dummy thermal loads.
Okay.
So this is not a full rolling vehicle, so the other kind of thermal components can be simulated.
Okay.
So we will kind of have a full vehicle worth of like thermal components on this bench, but that obviously kind of is going to be very testing focused setup. So we can run through tests and not have to go drive a vehicle through Death Valley or something. We
Right.
can essentially drive through Death Valley here, where we can turn some knobs and we can do that.
Got it.
In the office. So yeah, so we'll use this to help develop our control systems for kind of the different heating and cooling modes that the Aptera will be in, depending on ambient conditions and conditions inside the cabin and all the other factors.
Okay. So is this the simulated belly pan?
So this is our battery cooling plate,
Okay.
which is also pretty similar to the belly pan.
Okay.
They're both kind of flat plate heat exchangers
Okay.
with coolant that runs through them. So what we learned from this, so this is an early kind of sample part. So what we learned from this can help feed into the actual production parts. So we're not spending a bunch of money on production tooling without having any idea if it's going to work.
So there's two coolant pans. There's one for the battery pack and a separate one for the belly pan.
So the battery pack coolant plate will pull the heat out of the battery.
Okay.
And then the belly pan takes that heat and then rejects it to
Okay.
the ambient air.
Okay.
So there are two different steps in it, right? So
Right.
one's kind of absorbing heat, one is rejecting heat.
Okay.
Except when they flip directions when you're heating the battery up when it's really, really cold inside. So you kind of flip the purpose, but yeah, so that's generally how that works.
So the belly is composite, right?
No, so the belly in the production vehicle will be aluminum.
Okay, because I was about to say, like,
Yeah.
composite's not a very good heat
No,
exchanger.
exactly, you're exactly right there. So we're gonna have an aluminum belly pan.
Okay.
So that way we can really be very efficient in rejecting the heat.
I see. Okay.
Yeah.
And is that the control boxes? Is there anything there?
Yeah, so there's not quite anything in here yet. Controlling a test setup is a lot different than controlling the actual vehicle.
Okay.
So this pump here is huge, but it's linear, which is really nice.
Okay.
It's not very efficient.
Okay.
So for testing setups, it's perfect. You just be like, I want it in half. You can dial that in really easily. For kind of a centrifugal pump that's in most automotive applications because they're a lot more efficient. They're not very linear, so for testing setups, it's not as nice to work with.
Okay.
So it's all about measuring things well, getting the data you need, making sure it's clean so you can resolve any differences that you did make.
And have you guys decided what kind of coolant you're using?
It's just going to be 50-50 glycol water mix.
Just like regular antifreeze
Yep,
coolant,
exactly.
automotive
Yep.
stuff.
There's
Okay.
nothing special needed there.
Okay. And this, you said, it's the battery
Yeah, so what you're looking at is the battery cooling plate, and it's
Uh-huh.
actually an old version, so.
Okay, this is not the version that you would be using probably.
No, but this is an older version that we have made. We have simulations that this is correlated to.
Uh-huh.
So when you correlate your simulations, you have very high confidence in that you can use that simulation to iterate hundreds of times in the computer before you have to go
Okay.
spend money and wait.
Make another
Right.
model, right?
It's all about if you can get your simulations to be correlated, you can run through your designs and end up with something a lot better, a lot faster.
Okay. And so right now you're just trying to figure out like, can it run at extreme high temperatures or extreme low temperatures?
Well, it's
You're
that,
putting that
and then
kind of load on
it's characterizing kind of very specific factors on kind of the heat transfer coefficients. Now you can calculate and estimate some of those, but in the end, like they're inputs to your simulation.
Uh-huh.
So you need to characterize what those are first.
Uh-huh.
So you can put those in and use that for your simulation.
Okay.
You can, like I said, we started off with a pretty good estimate as to what those coefficients were going to be.
Uh-huh.
We tweaked them a little bit once we kind of got the data from this, and everything's lining up nicely.
Okay.
Yeah.